In software engineering, porting is the process of adapting software so that an executable program can be created for a computing environment that is different from the one for which it was originally designed. The term is also used when software hardware is changed to make them usable in different environments. Software is portable when the cost of porting it to a new platform is less than the cost of writing it from scratch. The lower the cost of porting software, relative to its implementation cost, the more portable it is said to be. Etymology: the term port is derived from the Italian porta, meaning to carry. When code is not compatible with a particular operating system or architecture, the code must be carried to the new system. The term is not generally applied to the process of adapting software to run with less memory on the same CPU and operating system, nor is it applied to the rewriting of source code in a different language. Software developers often claim that the software they write is portable, meaning that little effort is needed to adapt it to a new environment. The amount of effort actually needed depends on several factors, including the extent to which the original environment differs from the new environment, the experience of the original authors in knowing which programming language constructs and third-party library calls are unlikely to be portable, and the amount of effort invested by the original authors in only using portable constructs. History: the number of significantly different CPUs and operating systems used on the desktop today is much smaller than in the past. The dominance of the x86 architecture means that most desktop software is never ported to a different CPU. In that same market, the choice of operating systems has effectively been reduced to three: Microsoft Windows, OS X, and BSD Unix Linux. However, in the embedded systems market, portability remains a significant issue. International standards, such as those promulgated by the ISO, greatly facilitate porting by specifying details of the computing environment in a way that helps reduce differences between different standards-conforming platforms. Writing software that stays within the bounds specified by these standards represents a practical although non-trivial effort. Porting such a program between two standards-compliant platforms can be just a matter of loading the source code and recompiling it on the new platform. However, practitioners often find that various minor corrections are required, due to subtle platform differences. Most standards suffer from gray areas, where differences in interpretation of standards lead to small variations from platform to platform. There also exists an ever-increasing number of tools to facilitate porting, such as the GNU Compiler Collection, which provides consistent programming languages on different platforms, and Auto Tools, which automates the detection of minor variations in the environment and adapts the software accordingly before compilation. The compilers for some high-level programming languages gain portability by outputting source code in another high-level intermediate language for which compilers for many platforms are generally available. Two activities related to porting are emulating and cross-compiling. Porting compilers: instead of translating directly into machine code, modern compilers translate to a machine-independent intermediate code in order to enhance portability of the compiler and minimize design efforts. The intermediate language defines a virtual machine that can execute all programs written in the intermediate language. The intermediate code instructions are translated into equivalent machine code sequences by a code generator to create executable code. It is also possible to skip the generation of machine code by actually implementing the virtual machine in machine code. This virtual machine implementation is called an interpreter, because it reads in the intermediate code instructions one by one and after each read executes the equivalent machine code sequences of the read intermediate instruction directly. The use of intermediate code enhances portability of the compiler, because only the machine-dependent code of the compiler itself needs to be ported to the target machine. The remainder of the compiler can be imported as intermediate code and then further processed by the ported code generator or interpreter, thus producing the compiler software or directly executing the intermediate code on the interpreter. The machine-independent part can be developed and tested on another machine. This greatly reduces design efforts, because the machine-independent part needs to be developed only once to create portable intermediate code. An interpreter is less complex and therefore easier to port than a code generator, because it is not able to do code optimizations due to its limited view of the program code. Some interpreters are extremely easy to port, because they only make minimal assumptions about the instruction set of the underlying hardware. As a result, the virtual machine is even simpler than the target CPU. Writing the compiler sources entirely in the programming language the compiler is supposed to translate, makes the following approach, better known as compiler bootstrapping, feasible on the target machine: port the interpreter. This needs to be coded in assembly code, using an already present assembler on the target. Adapt the source of the code generator to the new machine. Execute the adapted source using the interpreter with the code generator source as input. This will generate the machine code for the code generator. The difficult part of coding the optimization routines is done using the high-level language instead of the assembly language of the target. According to the designers of the BCPL language, interpreted code is more compact than machine code, typically by a factor of 2 to 1. Interpreted code, however, runs about 10 times slower than compiled code on the same machine. The designers of the Java programming language try to take advantage of the compactness of interpreted code, because in Java a program needs to be transmitted over the Internet before execution can start on the target's Java virtual machine. Porting of video games. Porting is also the term used when a video game designed to run on one platform, be it an arcade, video game console, or personal computer, is converted to run on a different platform. Earlier video game ports were often not true ports, but rather reworked versions of the games. However, many 21st-century video games are developed using software that can output code for one or more consoles as well as for a PC without the need for actual porting. Many early ports suffered significant gameplay quality issues because computers greatly differed. Reviews complained of ports of Apple II series games like Crush, Crumble and Chomp not using superior Atari 8-bit features. Lord British stated in 1984 that Origin Systems developed computer games for the Apple II first, then ported them to Commodore 64 and Atari, because the latter machine's sprites and other sophisticated features made porting from them to Apple far more difficult, perhaps even impossible. The Apple version will never get done. Others work differently. Ozark Softscape, for example, wrote MULE for the Atari first because it preferred to develop for the most advanced computers, removing or altering features as necessary during porting. Such a policy was not always feasible. Danny Bunton stated that MULE can't be done for an Apple. Arcade-perfect video games are those that have been ported from an arcade version to another platform, such as a console or computer, without any alterations to the game's workings. This means that graphics, sound and gameplay, along with the game's other characteristics, are identical to the arcade version. Console port is a game that was originally made for a console before an identical version is created which can be played on a personal computer or any other console. This term has been widely used by the gaming community. The process of porting a game from a console to a PC is often regarded negatively due to the higher levels of performance that computers generally have been underutilized, partially due to console hardware being fixed throughout their run, while PCs become more powerful as hardware evolves, but also due to ported games sometimes being poorly optimized for PCs, or lazily ported. See also, software portability, language binding, console emulator, list of system quality attributes, source port, write once, compile anywhere, POShlib, cross-platform, program transformation. Notes. References: Martin Richards and Colin Whitby Strivens, BCPL, The Language and Its Compiler. ISBN 0-521-28681-6. Andrew S. Tannenbaum, Structured Computer Organization 10th print. ISBN 0-13-854605-3.